So next we're going to speak about tuning the zone-based policy firewall, inspection engine. So the stateful firewall engine, and I say stateful, which means what we're about to speak next is going to affect only inspect actions, because only inspect actions have to do with the stateful firewall capability. A drop action is going to be a drop action, it's going to drop the packets. A pass action is stateless. The router doesn't keep track of anything back and forward. So what we're about to speak next is going to affect only, of course, inspect actions. So the additional capabilities that we can use to actually tune the, let's say, overall security pretty much, to make the security stronger to the firewall, is that we can have what is called alert and audit trail. We can tune the engine's connection settings, timers and limits, and the TCP normalizer. Of course, it's a couple of more than this, but again, for the CCNP track should be pretty much this is what you should know. Before we get going, something else which it has to be very obvious. So we're going to do, as you see, we're going to do a lot of zone-based policy firewall. We're going to do a lot of ASA firewall. And you might think that, whoa, that's pretty much, that's a lot that I'm going to be good at this. It's actually a lot more than what we do in the CCNP class. So these settings I said are only supported for the inspect actions, not for pass or drop actions. Because for pass or drop, there is no stateful state of the session passing to the firewall. Let's take it one by one. Alert and audit trail. Now audit trail, if enabled, what that means is that the firewall is going to record connection, session, start, stop, duration. So when did the connection start? When was the connection built in a state table? How long was the connection active? When did the connection end or stop? And how much data was transferred to that session? And from who to who? What was the source and destination IP addresses of those sessions? It's going to record that data by generating a log message. Alert means that if you enable the alert capability, as firewall inspects traffic back and forward, the firewall generates log messages upon detecting suspicious activity or protocol inconsistencies. Which pretty much what this means is that the alert function is only valid if you inspect protocols, if you inspect the layer 7 protocols like Mesh Protocol FTP, Mesh Protocol TFTP, not really for like Mesh Protocol UDP. So the alert function, as I said, is the firewall generates log messages upon detecting protocol inconsistencies, which means for that to happen, to detect, for example, when a HTTP packet it's not per the standard, for example, does not conform with the standard, it means you have to match, your traffic has to match on a Mesh Protocol HTTP statement to detect protocol inconsistencies. But suspicious activity could also be detected via regular TCP matching, Mesh Protocol TCP, like for example, not an out of order packet, but an out of order sequence number, for example, which could be the signal that there is an attack happening because somebody tries to spoof the sequence numbers of a TCP session. And they make sense. Audit trail is like auditing what happened to the firewall. Alert means when something is wrong. And what can go wrong if somebody tries to spoof some packets, or there's a protocol inconsistency, which means somebody tries to send illegitimate HTTP requests or SMTP requests. Connection timers, like the sessions in the state table of the firewall, are going to be deleted from there based on the TCP closed events, like reset or fin. So because the firewall does, and now I'm answering probably also Matthew's questions in a better way. As I said, Matthew, I'm going to answer that question a bit later. So as a session is being built to the firewall, and if it matches an inspect action, not only the firewall keeps it in the state table, but keeps track of the state of that session. So like when the server and when the client and the server of a TCP session, if either of them is going to send a reset packet, then the firewall is going to also remove that session from the state table. When the session ends via fin flags between the server and the client, likewise the router is going to know, oh, so that session is closed. I'm going to also remove it from my state table. That's for TCP sessions. For UDP sessions, because those are connectionless, then the firewall has the default idle timeouts for some of the protocols. You're going to have a default idle timeout for UDP sessions, for DNS, for ICMP in there. Because UDP traffic is connectionless, so there is no reset or fin over UDP session, is just traffic flowing back and forth. So the only way the router could actually know when to remove an UDP session from the state table is based on some timeouts. Like if the session was idle for a specific timer, then I'm going to remove it from the state table. Also, SYN timeout, which prevents TCP SYN denial of service. The SYN timeout controls how long will the firewall wait for the TCP two-way handshake to be completed. So like if we go LAN to internet with a TCP session, and that's inspected by the firewall, so the firewall sees the SYN packet, is going to put an entry in the state table for that session, source destination IP, source destination TCP port numbers. The firewall is going to wait the default SYN timeout value. So if the router doesn't see the SYN ACK and the ACK, which means the three-way handshake being done in the SYN timeout interval value, it is going to kill the session from the state table to defend against denial of service attacks. Like imagine as it was the case where this was my telnet service, this was my telnet server in here. This was my telnet server, which is reachable from the internet via my firewall, via my zone-based policy firewall configuration. And from the internet, somebody could send a lot of SYN messages without ever completing the three-way handshake. So that looks like a denial of service attack, right? The router is going to kill each of those entries when they reach the SYN timeout value from the state table. Also, you have the fin timeout, which controls how long will the firewall wait for fin ACK. Because if I have a session, a TCP session, as I said before, between PC A and server A, which passes through my firewall and matches an inspect action, that's a TCP session. Now, a valid, let's say, TCP speaker, like this was an FTP session, let's say, when the client has downloaded everything, then the client should kill the data plane session. The client should send over to the server a fin message saying, I'm done downloading. So you're going to send a fin message, a TCP fin message. And the server should send a fin ACK message saying acknowledged. So the fin and fin ACK allows both the server and the client to also remove that entry from their tables, like the server and the PC, to remove that connection from their connection table as well. But it can happen that sometimes, for a lot of reasons, the fin ACK never comes back. Of course, that could be an attack as well. But if the fin ACK doesn't come back, server A never sends the fin ACK, or fin ACK is never received by router 1, then how long will router 1 keep that session in the state table? That's the fin timeout value. Connection limits. It provides protection against denial of service attacks. So with the connection limit functionality, the firewall controls the maximum total number of embryonic TCP connections, which means how many connections can remain without a three-way handshake being established. It controls the maximum number of embryonic TCP connections per host as well. So the first statement controls the total amount of TCP embryonic sessions that can reside in the firewall state table. The second number controls the total number of TCP embryonic connections that can reside in the firewall state table per host. It also controls the maximum total number of sessions that can exist in the firewall state table. So it doesn't matter if those are TCP, UDP, ICNP, doesn't matter which kind. The maximum total number of sessions. Because of course the firewall has a limited memory. The firewall cannot sustain in the state table millions of connections, right? So somebody could initiate a denial of service, not like a SYN flood attack, but like somebody from the internet could initiate a lot of many sessions, like thousands or tens of thousands. If those are TCP with 3 handshake being achieved, so there are valid sessions, but because there are too many, then router 1 may remain out of memory because he cannot put in the state table like hundreds or thousands of millions of entries, because that state table is kept in the memory and the memory is not unlimited. Now we have the TCP normalizer, which by the name is going to normalize TCP packets. It prevents evasion techniques used by attackers to bypass application layer filtering. Now the normalizer, in this case, it's active only if application filtering, which means deep packet inspection, is configured. With Mesh Protocol FTP, you don't do deep packet inspection. You just make the router to look at the application header to allow that return session, that data plane session backwards in, as it was the case of FTP. So that was not deep packet inspection. That was just layer 7. That was just you are making the router to be protocol aware, because that protocol has a special functionality which makes use of multiple sessions, and you want to allow that traffic to work through the firewall. Because again, this prevents techniques used by attackers to bypass application layer filtering, which makes sense. This is enabled, the normalizer, only if you do application layer filtering or deep packet inspection. Also, TCP normalizer, it reassembles or normalizes the TCP stream for proper application layer inspection. So that's what it does. And it also deals with out of order TCP packets. With out of order packets, TCP packets. Now, let's see how we can control all of those settings: the normalizer, audit trail alert, and the connection limits and settings. To understand that, we have to introduce a new, let's say, object in the zone-based policy firewall configuration, which is called the parameter map. Now, parameter maps define advanced or special inspection settings used by the zone-based policy firewall. There are several types of parameter maps, but most importantly, we're going to speak about the following types: the inspect parameter map type, the OOO, which stands for out of order type of parameter map, and the regex one. We're going to speak about the regex one when we go to deep packet inspection and application filtering. Now, the inspect parameter maps control audit trails and alert settings, and also control connection settings. The out of order parameter maps control, as expected, the TCP normalizer settings, because TCP normalizer also deals with out of order packets. The regex parameter maps define regex expressions used for deep packet inspection for all policies. Now let's speak about the inspect parameter map type. A default inspect parameter map exists, which is also named default, which is applied by default to all classes of traffic would inspect actions. Because I want the file to have some default settings to how the engine runs. Like what are the default connection limits? What are the default connection timers? What are the default configuration for audit trails and alerts? So there is a default parameter map called default, which is by default applied to all classes of traffic would inspect actions. Why only would inspect actions? Because tuning the engine, the inspection engine, means only this only affects inspect actions. As I said it before, it makes sense. Because if you do pass or drop, we don't inspect anything at all. We either pass the traffic or drop it, but we don't care. We don't keep track of the session state. So it makes sense that it's going to be applied, the parameter map, the default one, to all classes of traffic would inspect actions only. Now, of course, additional inspect parameter maps can be configured. You can use that in order to change the default advanced inspections for specific classes of traffic. So what that means is that if you're not happy with the default settings for audit trails, alerts, connection limits, connection timers, then you can build your own parameter map of type inspect, as you're going to see. Change the settings and then apply those settings to whatever class of traffic you want. Now, the zone-based fallacy firewall out of order parameter map, a default one exists. It is named global because it is applied globally, not under a class map or under a policy map, just globally applied. That's why it's called global. And it affects all traffic inspected by the firewall. Because it is applied globally, additional out-of-order parameter maps cannot be defined. And it makes sense because the normalizer, the TCP normalizer, let's say, capability of the firewall is being controlled by out-of-order or OOO parameter maps. And because that is resource intensive on the router, at this point Cisco doesn't let you to have, per class of traffic type, the normalizer engine to run differently. So you have only one global policy which affects the normalizer engine for all firewall traffic policies. Doesn't matter from which zone to which zone, doesn't matter. So they don't let you to have a different TCP normalizer engine setting, different TCP normalizer engine settings per type of class. Now, configuration wise, what we do is we're going to speak about, of course, first of all about the inspect parameter map. We configure a new inspect parameter map. We define the settings. We change in there the connection limits, the connection timeouts, whatever we want, the alerts, the audit trails, and settings which are not configured in there. Let's say we want to change the SYN timeout but nothing else. So whatever we don't configure specifically under our own configure inspect parameter map are going to inherit the values from the default parameter map. So we configure our parameter map of type inspect, and then we apply it. We apply those settings. We tell the router how to do advanced connection inspections. We apply that parameter map for one or multiple classes of traffic. For which classes of traffic do we want the firewall to do advanced inspections as we configured it? Of course, if you want, you can change the settings from the default one. It's up to you. So instead of configuring a specific parameter map, you can go and change the parameter map's default settings. Verification wise, we verify the parameter map settings with the command show parameter map type inspect and the name of the map, or with show parameter map type OO global for the OO type parameter map. or with the old command, with the new command show policy firewall config parameter map. So the first two commands are the, let's say, the old commands. The last one, show policy firewall config parameter map, is going to be like the new command to verify your configured and default parameter map settings. And then we verify which inspect type parameter map is used for which class of traffic with the command show policy firewall config zone pair. And you're going to see in there that under each class map with an inspect action, you're going to see which parameter map is applied. A question from Matthew: so we can use the firewall as opposed to CPP or CPPR. What I did so far, Matthew, it affects traffic transiting the router, not distant to the router. CPP and control plane policing and control plane protection have to do with traffic generated by the router or distant to the router. So we're not there yet. So what we have spoken so far, it affects only transit traffic transit the router, not destined to the router or initiated by the router. We're going to get there as well when we speak about the self zone. Now let's speak about also PAM. PAM stands for Port to Application Mapping, which is very self-explanatory. The router has a predefined mappings for well-known protocols. Like for example, the router knows that TCP traffic destined to port 21 is the FTP control plane session. That's how when we said previously match protocol FTP, the router knew what to inspect, which means TCP traffic on destination port 21. So it's the PAM controls port to application mappings. So in zone-based policy firewall, PAM is used by match protocol statements within a class map, like match protocol FTP, match protocol HTTP, and whatever application protocol you're matching with the match protocol statement. Now, if a well-known service like FTP runs on a non-default port, like on port 2121, and you want to inspect FTP traffic, it means that PAM settings need to be adjusted accordingly. As you're going to see, because if I have that FTP session running over TCP 2121, the router is not going to let that session to work at all. Because by default, from the router's point of view, FTP control plane session runs on port TCP 21, not on TCP port 2121. Now, to change those settings is very simple. We just globally configure PAM accordingly to match on the non-default port of that application. And optionally, we can also remove the default mapping. So as you're going to see, if we run, if in our network, let's say in a closed network, we run FTP on port TCP 2121, and we don't have any FTP servers to run on port 21, the default one, then we're going to configure PAM settings for FTP to let the router know that FTP runs on port 2121, and we can also disable the default settings which tell the router to run to that FTP runs on port 21. Verification wise, we verify the port to application mappings for a specific protocol with command show IP port map in a protocol, like show IP port map FTP, show IP port map TFTP, whatever we want.